Welcome to this presentation on behalf of my co-authors, the members of the ECETOC Task Force on Polymer Safety. ECETOC is a science organization connecting scientists from academia, government, and industry. The ECETOC Task Force has developed a conceptual framework for human health and environmental safety assessment of polymers. The case study on cationic polymers will illustrate benefits and shortcomings of the risk assessment framework. The ECETOC Polymer Task Force reviewed scientific and regulatory approaches to assess polymers that resulted in the development of a conceptual framework to guide risk assessment. During that process, challenges in the applicability of test methods were identified, which are documented in the second technical report. Finally, the applicability and flexibility of the conceptual framework for risk assessment were evaluated with case studies. In total, 7 case studies were selected from the diverse universe of polymers. The conceptual framework comprises of 8 steps, as shared in this high-level overview. The problem formulation is an important element, as polymers are diverse in chemistry and in application. It is followed by a definition of the polymer identity, which is an important element as classical identifiers such as Cas numbers may not be the best descriptor. Polymer component strategy define which component of the product shall be addressed. For example, the assessment may focus on the polymer product, or the polymeric substance, or low molecular weight components such as intentionally and non-intentionally added substances. In the grouping, the aim is the identification of read-across sources to avoid unnecessary resource allocation to hazard characterization, especially with regards to animal testing. The exposure characterization identifies routes of exposure to humans and the environment. Hazard assessment aligns to the polymer component strategy and relevant to the life cycle stage assessed. Cationic polymers are a broad class of polymers with different types of backbones and a net positive charge. The charge includes phosphonium, sulfonium, and ammonium cations. However, nitrogen groups are the most common cause of cationicity in polymers. Many cationic polymers are also water-soluble or otherwise water-dispersible and are regarded as posing a hazard concern towards aquatic species. Available data show that aquatic toxicity is related to the charge density of the polymer. In fact, QSRs developed by the US EPA several decades ago point to the charge density as a driver for aquatic toxicity. Among cationic polymers, the case study focused on polyquaternium 6, or named PQ6, and polyquaternium 10, also named PQ10. On the basis of their intended use in personal care products and as flocculants in wastewater treatment plant, the polymers may be present in the aquatic environment. While the environment is the prime focus of the study, the review was performed for both human health and environment. The international nomenclature of cosmetic ingredients, or INCI names, of the cationic polymers addressed in this case study are PQ6 and PQ10. Both family of polymers have shared characteristics in the sense they contain no additives and have a low level of impurities. As indicated, the polymers may fall under different Cas numbers. The green box points to the specific characteristics of interest in this case study, which have high molecular weights, indicative of likely low systemic bioavailability. The nitrogen charge density is sufficiently high for these polymers to not qualify as polymers of low concern. Indeed, the functional group equivalent weight, or FGEW, is below 5,000. This slide discusses how key polymer properties inform on the fate and distribution in the environment, including biota. KW, a metric used to inform uptake in biota and environmental partitioning of selected organic chemical substances, is not applicable. Rather, cationicity and molecular weight are relevant for those polymers. Due to the high molecular weight, uptake in biota and systemic bioavailability are unlikely. Cationicity informs on the type of interaction with surfaces. Therefore, sorption processes play an important role. Sorption is in fact equally important to understand aquatic toxicity and partitioning between environmental media. On the top path, sorption may lead to physical effect in aquatic species, such as the prevention of oxygen exchange in fish gills or entrapment in smaller species. The lower path illustrates the importance of sorption to inform on environmental fate. Metrics such as the adsorption coefficient to sludge are viewed as relevant parameters to inform on partitioning and removal in wastewater treatment plant. Finally, sorption will likely mitigate the aquatic toxicity potential in their natural environment, as TOC is greater in the aquatic environment than in standard testing guideline. In consequence, sorption processes influence the exposure level in the natural environment as well as the potential for aquatic toxicity. Therefore, there is a need to further explore how the charge density may be correlated with the environmental fate and ecotoxicological endpoint. The use patterns inform on exposure routes. Both polymer types are used in personal care, thus may be emitted to wastewater treatment plant. In addition, selected PQ6 are also used as flocculants in wastewater treatment plants, and therefore are directly dosed in wastewater treatment plant clarifiers. From a human health perspective, exposure from personal care product may occur on the scalp, hair, skin, as well as the eyes. Worker handling PQ6 in the professional environment are advised to handle chemicals following the safety measures. Exposure assessment is based on qualitative exposure, since there are challenges with the domain of applicability and parameterization of partitioning, for example, in wastewater treatment plant. As indicated, the propensity of the polymers to sorb to surfaces may lead to physical effects. Current research is further expanding knowledge about the key polymer properties informing aquatic effects. Charge density is understood as being a driver for the hazard. However, the role of other polymer properties such as molecular weight are being evaluated in the Cefic LRI ITAP project. Standard testing approaches to characterize aquatic effects may exhibit artificially high toxicity due to the low total organic carbon in the test media. They provide a worst-case identification of hazards. However, mitigation factors are important to characterize in order to support an environmental, realistic risk assessment. With regards to human health, the polymers do not exhibit systemic toxicity on the basis of their low systemic bioavailability. Some polyquaternium may exhibit mild local irritation at concentration exceeding realistic human exposure. The case study has demonstrated the need for fit-for-purpose risk assessment and illustrated some complexities from polyquaternium polymers in characterizing the hazard and fate assessment. Molecular weight and charge density were identified as relevant polymer characteristics to inform on the environmental fate and bioaccumulation. The review identified that experimental study designed to inform on aquatic hazards need to be considered carefully as to inform on hazards that would occur in the environment. We also acknowledge that there remains a knowledge gap with regards to key properties characterizing fate and exposure. Cationic polymers are a diverse group of polymers. Considering that this case study focused on two polymer types, there are remaining uncertainties about the key polymer characteristic that would support a grouping across the wide range of cationic polymers. The case study did reveal, however, specific polymer characteristics to inform on potential grouping. For example, for ecological endpoints, there is some indication that the sorption, for example to sludge, of different variant of PQ10s increased with increasing charge density, and that PQ10s with high charge versus low charge exhibit different aquatic toxicity potential. I thank you for your attention and welcome questions in the chat.